Today, we are going to learn how to create static libraries in C, basically on Ubuntu, using AR command, the archiver utility, provided on most Unix-like systems. So by the end of this particular session, you will be able to understand what the static library is, how to create one from the object files, how to make use of AR command effectively, how to add or update objects or object files into existing library, and how to make use of this library with the another program. So first of all, let us try to understand what exactly the static library is. Static library is a file that contains compiled code in the form of object files, which further can be linked into a program at compile time. Now, these libraries typically have a .a archive extension. Unlike dynamic or shared libraries, that is .so files, static libraries are included directly into the executable during the compilation. For example, like if I have a libm.a for math functions, then I can think of like having a sine and cos functions added in that particular library. Now, the tools that we will be using here are GCC to compile the source code into object files, AR to create or maintain the static library, and then we will execute this code simply. So let us see the step-by-step process to create rather this archive library. So we'll try to write few functions, okay, in our code. So we'll create static. I will add my all programs here. Fine. So let us add, say, let us create a function. Okay, like I will create add, subtract, multiply, division, and so on kind of functions. So let us say sum.c. So let us include stdio.h, and the function that would be writing just would be returning the result. Okay, so let us write this int sum, which is going to take integer a and integer b as parameters, and simply will return a plus b. Done. Fine. So this is our first sum.c. So let us save this as subtract.c. So here instead of sum, I will write subtract. Okay, and here I will return this. Fine. Let us save this to again mul.c. Here we'll write multiply, and here the multiplication would be returned. Okay, now let us say we have these files available with us. Okay, which are like each one of them is containing say appropriate operation. If I see less sum.c, this is containing addition. Further, like we created subtract.c, and then we created multiply mul.c. Fine. So the function names are written as like multiply here. Then for subtraction, we wrote subtract. And for addition or sum, we wrote capital sum. Fine. Now let us create the object codes for all these three. Sum.c and write dash c. Now we know that this dash c flags creates an object code. So the file that is created here as an object code can be checked as an like .c is object source C source ASCII text, but when I write .o, then it is 32-bit LSB relocatable, correct? ELF. So now we have for sum .o. Similarly, we'll create it for subtract.c, and similarly for mul.c. Now, as we have all these three files readily available with us, now our task is to now create a library. Now here we are going to make use of an utility on Linux, okay, which permits us to create an archive library. Okay, so for that purpose, one can write here man AR. Now, if we see this AR utility actually is used for like creating an archive library. So it is called as archiver. It is a utility available which permits us to create, modify, and extract from archives. Create archive, modify the archive, or extract from the archive. So archives are like single files that bundle together multiple object files. In the context of like software development, AR primarily is used to create static libraries, files that end with extension.a. Now it is kind of one can say that it is like a zip file for object code, but designed to be used by compilers and linkers. Now, why should we use this AR modular programming first? Like you can compile functions separately, group them into a single reusable file. Performance perspective, static linking can improve runtime performance since all code is embedded in the final executable. One bigger advantage here is portability. A file can be shipped as a library and used without needing the source. And developers can definitely manage and update object files inside a single library file. So for this purpose, as we'll be using AR, so this will build, say for example, a library name is say my library, say then my library.a, for example. So one can have custom utility libraries, like if, like for example, you can create some library, like if you are creating for string functions, you can give it like a string my string dot l dot a kind of correct. So to you make use of this AR, so let us first of all add the things. Okay, create the things. So we already created this three object codes. Okay, let us create using R. So simply write AR, then RCS, then your file name. So I will prefix lib mylib.a as the name of my archive. Okay, and then simply add your object code names sum.o, sub.o, and mul.o. Now let us see whether it is has it created. So when we see here towards the end, the file is added there. Correct. So let us check the contents of this file. So to check the content, to list the files available in archive, so you simply make use of -t. So you give now your library name. You can see these files are. Now suppose we want to add one more function over here. Okay, for division. Okay, which would be in another file. So let us copy this mul to div.c, and we will create now this div.c. We already created the file, okay, with the object codes. Now simply we'll give here different name because we want to add division. And then here I will write it is returning float. Fine. So let us compile div.c. Okay, this will give us now we have div.o created. Now, as we saw with our earlier library, we had only three object codes included. Now we have to add this new div.o. So what exactly you can do is you simply write AR. Okay, then you write RCS. Again, same thing. Now I will let you know what exactly RCS is. RCS, then your library name .a, and then what are the file that you want to add. Now if I check it now again, AR-T. Now you may see like the way that we added that particular div.o particularly. Okay, now this is added as an part of the library file. Now here I used R. This R is meant for inserting files into archive. Replace if it is already present. C is for creating an archive if it doesn't exist. And S, like this creates an index, that is a symbol table to the archive, which can be used for speeding up the linking. Now, as we created this library, like here, like for example, if you want to remove even if you want to remove an object file, that also can be done. So to do so, you simply write AR D, okay, then your library name, okay, and the file name that you want to remove. Okay, now if I again write this, you may see it is removed. So we'll keep it added, okay, for the sake of writing. So let us write now a function which will call this library or this library functions. Now, as they are part of different, what you can call it as files, and then we bundled it together as a .a. So let us include first stdio.h. Okay, let us write main. Let us take integer a equal to 15, integer b equal to 4, and simply let us call the functions. Addition of %d and %d is %d slash n. Then we'll use function name, okay, a comma b, and as we are printing the values also, so addition of a b is sum of a b. Fine. So this we did for sum. Similarly, let us write for sub. Okay, let us write for multiply. Okay, so we will check what the name we gave. So less mul dot c. So we give multiply, and for a division, we are given division, multiply and division. So let us use them here, multiply, and here division. Simply we have to make a small change here as percent and then return 0, bracket complete. Now, as we are aware that these functions are not part of this file, so it is better always to declare the prototype. So integer sum int comma int semicolon. So it is next is sub. It is multiply, and then we had float division int comma int. Fine. Now let us like as we created this file, let us link it together with respect to our archive. So let us write it, compile the file. So the code name we gave is my main, and if I write this, then you will see an error there. Okay. Okay. So we'll correct this error first. I wrote it earlier. And so I should have not written this. Correct. Now you will see there is an undefined reference to sum, sub, multiply, and division because we have not linked it with our code. Correct. So to do so, like what exactly can be done is now let us see first of all what we created. So we have my main, we have lib mylib.a and so on. So let me write GCC. Now I have to link it. So my main program name is my main.c. Now you write dash l dot search in the current working directory, then write dash l. Then like you may realize here, like I have given name of the file for an archive library is libmylib.a. Now I can write here directly mylib. Assumption here is that lib is prefix, and when you write dash l, that lib is already there. Right. So if I compile this and link, so let us see what exactly it is saying. So maybe like the function that I used is not the proper one. Okay. So let us go and check with the files. So like even div.o file which we created is not of 64. It is not of 32 bits. So let us go back and write here dash m32. Now this error would be removed. Other error will remain. Okay. So at least we have to create that library again. RCS. Okay, we'll remove first div.o, control R, AR, D. Sorry, I wrote C, AR, D. Okay, then again ARC. We'll create RCS div.o. Now, if I compile it again, you will see that error of div is removed. Now we have to see this. So the function name that we used here in sub.c, it is subtract. Okay, and let us see in our code what we wrote. So we must have written sub. Yes. So it should be subtract. Fine. Above also. Now let us link. Now you will see that our code got executed here. Correct? So what we exactly carried out here as a process perspective, we created a library. Okay. To create a library, first of all, we created object codes. Once the object codes are created, we added them using command called AR RCS. Okay. Like this. Let me, yeah, like this. So we created AR RCS libmylib.a, sum.o, sub.o, and mul.o with assumption. Sum.c, sub.c, and mul.c were there, using which we created the object codes. Later, we saw how to add another .o into this existing one. So to do so, we created math, div.o. So control R, say div.o, and then we simply added that here. Correct. So, and further, we even saw, like, if I want to delete, how exit deletion can be done. So we used ARD. Right? And this is how you generally create the libraries and use it. Now, one option that I showed you here, like with respect to this, you must have seen that when I displayed my library, okay, say this one, name of the library is libmylib.a. But while I used it with -l, ultimately the prefix is assumed. Lib is the prefix which is assumed. So I simply have to write mylib.a. Now, another mechanism probably could be like, let us first delete a.out. Now you can do this too, like gcc -m32 my main.c and simply write your lib archive file name. This also can be the mechanism that you can make use of to create a static library. So what we saw here, that AR tool, which is available on Unix from so many days, rather so many years, I should say, still it is used because it provides importance and reliability in respect of making use of static libraries. Fine. Thank you.